much like in Calculus 1, there are some properties of double integrals, and these really are properties of integrals of functions of one variable from Calculus 1. So Theorem 14.1, properties of double integrals. If f and g are continuous over a closed bounded plane region R, and c is any constant, then the integral of that function of two variables, dA, remember that could be dx dy or dy dx depending on which one is decided to go first, and over the region R with a constant, the constant factors out. So just as in integrals of functions of one variable, constants factor out. And the sum or difference of two functions, dA over the region R, is the first one plus, or it depends if it's a sum or a difference, plus or minus the second one. So these two together would say integration is linear, for what it's worth. Here's another property. If the function f of xy is always greater than or equal to 0 over the region R, then the integral of that function over that region R is always greater than or equal to 0. Only be equal to 0 if this was the 0, f of xy equals 0, unless our region R was had area 0, which not much of an integral then, would it be? So, and here's another one. If f is bigger than or equal to g on some region R, and they're both two variable functions, we assume, then the integral of f is bigger than or equal to the integral of g over that region R. And that's also very logical. If you think about it, that means these boxes are bigger than or equal to these boxes. And finally, if the region R is made up of two non-overlapping, that's important, they can't be overlapping, subregions R1 and R2, then we can find the double integral over the subregions and add them to get the integral over the total region R. Now, that's kind of like saying if you wanted to integrate from A to B in single variable calculus, integrate from A to B and there's a number C in between, then you can integrate from A to C and then integrate from C to B. So that's kind of the same thing. Here's the way it would look abstractly, and here's a picture to show you why that's true. See, we could integrate over, although it wouldn't be too easy to find limits of integration if it was shaped like this, we can integrate over R1 and integrate over R2 and add those two together. That would be equal to the integral over the whole region R. So that gives us some nice properties of integration, and we'll be evaluating double integrals. We've done a few already, but we'll do some more of that in the next video.